What is the bond in a molecule of iodine? So iodine is I and I, which means that it's got an electronegativity difference of 0, meaning that we are going to have it's two nonmetals, so it's going to be covalent, and then it's going to be nonpolar because they have the same electronegativity, and it's the bond, it's not the intermolecular force. Which of the following substances is an example of a solid with a high electrical conductivity and which melts at approximately 200 degrees centigrade? So the first thing is it's got to conduct electricity, which means it needs to be a metal. That's going to bring us down to only one thing over there. It doesn't say it only conducts electricity when it's melted or anything like that. It is conducting electricity all the time. So the only metal there is sodium. How many atoms are there in 0.23 grams of sodium? So the first thing we need to do is decide how many moles there are. Number of moles is equal to mass over molar mass, which is going to be equal to 0.23 divided by 23. That turns out to be equal to 0.01 moles. And then I'm going to get number of particles is equal to number of moles times Avogadro's number. So it's going to be the 0.01. I'm going to multiply it by 6.02 times 10 to the 23, and I'll end up with 6.02 times 10 to the 21. A Lowry-Bronsted base is a substance that, so this is really just a definition, it is a proton acceptor, so there's the answer. In the reaction that is given over there, what is water doing? So we first need to identify our acid-base pairs. We've got a proton donor over here, so that is an acid, and when it's donated it becomes that base. And then we have got a base over here, which when it accepts a proton becomes this acid over here. So the water acts as a base. So we're going to land up over there with a base. Then phenolphthalein is a pinkish color in a basic solution. Which of the following substances, when dissolved in water, will cause phenolphthalein to become pink? So we're looking for something that is basic. Hydrogen chloride is an acid, so that's definitely not going to happen. Ammonia is a weak base. Sodium chloride is a neutral salt, coming from sodium hydroxide and hydrochloric acid, a strong acid and base. And methane really doesn't dissolve in water very well at all and doesn't have acidic or basic properties. So the only answer there is ammonia. We've got blocks of waste magnesium that are attached to the hull of a ship to protect it from rusting. The main component of rust is iron. So we now need to look at magnesium, which is over here on the redox table, and we're looking at ion. So there's quite a few different ions over here. There's one there, and there's one there. The magnesium is doing what? So actually what's happening is the magnesium is turning into ions more easily. So it is oxidized, and then in being oxidized, so going like that, it donates electrons to the hull of the ship, and that is what causes it. That's a spontaneous reaction. So A is your correct answer over there. The following electrochemical cell is given. Possible electrolytes that could be used. So in X, it's got to be zinc something or other. Zinc nitrate's my favorite. So I'm going to go with zinc nitrate because it is my favorite, but there are others that could be possible if necessary. My favorite for the salt bridge, as I've said to you, is potassium nitrate, and it turns out silver chloride is not soluble, so you definitely can't use these chlorides over there. And then again, my favorite for silver is silver nitrate. Oh, thank goodness, so that turns out perfectly. The others probably have some insolubility rules, and as I've told you, the solubility rules are a bit of a bother to learn. But the truth of the matter is that silver chloride is a problem. Zinc sulfate is going to be insoluble. Zinc sulfide is going to be insoluble. So potassium bromide and potassium iodide are also not very soluble, at least potassium. Silver bromide and silver iodide are both not very soluble. So the three soluble substances, salts, are given by D. What is the correct IUPAC name? So we've got three things over there, which means that it's going to be prop. That doesn't help me, they're all prop. And then we are going to have dibromo, so it's going to be 1,2-dibromo 2-fluoro propane. So that turns out to be A. And last but not least, consider the following series of reactions. Which of the following identifies compound X, Y, and Z? Well, the first one is compound Z. They've given me quite clearly a whole bunch of esters. So if it was propanoic acid, I know that I must have had propanoate. So it's propanoate and propanoate. And I must have had some ethanol to make that true. So ethanol has to have started. Aha, there we go. We've got very little else. And then, is it reasonable that ethene could undergo an addition reaction and become ethanol? That certainly seems reasonable. So D is a good answer. Octane can undergo incomplete combustion according to the following equation. When does incomplete combustion occur? When there is a shortage of oxygen. Calculate the mass of carbon produced if 4,2 moles of octane is combusted in this way. So we're going to say, I'm going to look at octane and soot. The balancing numbers are 2 is to 6. I've got 4,2 moles. So I didn't even have to calculate that, which means that I have to multiply that by 3, 12,6 moles. And then I am going to say mass is equal to number of moles times molar mass. So it's 12,6 multiplied by 12 because it's just pure carbon, and I land up with 151,2 grams. Write a balanced equation for the complete combustion of octane. So complete combustion gives you two products. The one is water and the other is carbon dioxide. And then we need to balance that. So we're going to look at the carbons first. We're going to go 8 carbons, and we are going to look at the hydrogens. Next, we're going to go 9 hydrogens. That leaves me with an inconvenient number of oxygens. I have got 16 plus 9, which means I've got 25 oxygens, which means that this is going to be 12 and a half. Well, that doesn't help me terribly much. I now need to double everything. So it goes 2, 25, 18, and 16. Alcohols are very versatile compounds with a variety of uses, one being the preparation of other organic compounds. The following flow diagram shows that how propanol can be used to react to produce 3 different compounds. There we go. Draw the structural formula of propan-2-ol. Structural formula means I need to put everything in, and the 2-ol means that the alcohol group is over there. Then the next thing is, will propan-2-ol or 1-ol have a greater boiling point? Explain your answer by referring to intermolecular forces. And that's really important that you don't talk about bonds here. So the first thing is that 2-ol is a branch chain, whilst 1-ol is a straight chain. Therefore, 1-ol has more surface area, more points of electrostatic attraction. And therefore a higher boiling point. Compound Z is propene. Name the type of reaction represented by E. So we are over here, and we are going from propanol to propene. That is an elimination reaction. It is some sort of an elimination, but it's more than that. It's going to get rid of the ol, so it's actually going to be a dehydration, because we're going to lose a water by getting rid of that. But I would have accepted elimination. It didn't say what is the specific type of reaction. If it was specific, they definitely want dehydration. Write down the condensed structural formula for Z. Condensed structural formula, it's ethene, so it's C3CH, CH2. And condensed means I don't have any lines in there, and I'm just putting what's on each carbon. And then the next one is compound. X is 2-bromopropane, which is prepared by the reaction given. Write down the molecular formula of X. So we're on to molecular means I just have the molecule, atoms. So there are 3 carbons. There's going to be 7 hydrogens and 1 bromine. Propan 1-ol and ethanoic acid are reacted together in a heat bath in the presence of sulfuric acid. So this is obviously an esterification reaction. It's going to come up in the exam. You've got to get these right. Using structural formulae, show the balanced chemical reaction between ethanoic acid and propanol. So you have to do the whole structural formulae here. So the first thing is you've got your ethanoic acid, your propanol, and you're going to get water and you're going to get an ester. And your ester is going to comprise the alcohol first. You can do it the other way around. A mirror image is fine, but I'm showing you a way to get it right. So there's your alcohol bit, then your O in the middle, then OCO, so then I've got 2 carbons which are represented now, and that is my ester group, and only then do I fill up with hydrogens. Now be careful not to get too excited about your hydrogens, because what quite a lot of people did is they stuck a hydrogen over here. There isn't a hydrogen over there. There's already a double bond onto the oxygen there, and then name this stuff, and it is going to be propyl. Remember, the alcohol always comes first, and then ethanoate. Use structural formula to draw this 2,3-dimethyl butane. So let's draw that out quickly. Firstly, it's 4 carbons. And on the second one, there's going to be a methyl group, and I have to do a full structural formula. And on the first one, at least the second one, there's also, doesn't matter which way these go really. Sorry, running out of space here. And then fill up with hydrogens. Make sure that all of those carbons have got 4 bonds. And then finally name this organic molecule over here 1, 2, 3, 4, 5. So it's going to be pent. And then there is a double bond here and a double bond here, and we are there on number 1 and 3, so it's 1,3-diene.